So this is my first attempt at more swastika math. We all know that this sums to 19,291, which is one magnet above 3858 times 5. So my first attempt at this. And then I had to go to work today. I went to work today, and before work today, I did that. Okay? That's all I did. One page of swastika math. Okay, now understand this one thing is that the swastika itself is one image. But then you have 1, 2, 3, 4 pieces of white space. So there's like 5 sections of a swastika. And 5 times 3858 is 19,291, which is the sum of the actual swastika. So I wanted to relate something today about the white space in the swastika and how it means 3858 or something like that. Right, so this was version 2, and that was version 1. Then I had to go to work for 8 hours, and after work, I made version 3. The version 3 is pretty much awesome, okay? This right here, yeah. I don't know what I'm going to do with the music and movies and whatnot, but I got inspired today because I watched Inglourious Bastards, and they're hunting Nazis. Okay, I don't know why Jews think they have free reign over, like, making fun of Nazis and their Jewish media productions, but they do. So this is the 9x9 reckoner, okay? And that is essentially the sections broken down. I made a little gaff here, it's just an L. Okay? So, you know, the swastika is one shape, sums to 19,291, or 3858 times 5, plus 1, because I think there's a 1 magnet needed at the end. The 4 quadrants apparently come to 3858 when you account for everything. Now this statement is what this page is about. 1 swastika, 4 quadrants, or 5 things. 5 times 3858 is 0. But anyway, I digress. So let's take a look at the matrix, or the reckoner. Cool. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. There you go. A ring is equal to a 0 is equal to a 1. They're all equivalent. Everything's a 1. So every time I see a 0 here, or a ring, it's a 1. Except when it's in, like, you know, 13's a 13. It's not like a 0 or a 1 and a 3 at this point. So quad 1, there's 12 entities here, 12 entities here, 12 entities here, 12 entities here. They sum to this, 35, 261, 298, and 3657. Now, if you sum them all together, you get 4251. 4251 is way above 3858. But you didn't account for the numbers, or the amount of, like, the number of cells. You didn't account for the number of numbers in the cells. You didn't account for the sum in base units of those 4 quadrants. So, like, you know, I'm accounting for everything. So you sum them up together, you get 4251. You know that you have 12 cells per quadrant, you have 48 cells. Now in those 48 cells, okay, you have 12, right? But in the first quadrant, you have 1 double character, so really you have a 13. In the second quadrant, you have 19 numbers in those 12 cells. You have 17 numbers in those 12 cells, you have 32 numbers in those 12 cells, you have 81 numbers in the cells. Okay? 48 and 81 is 129 total. Okay? Now if you, I don't check my math yet, but I'm pretty, like, stoked with my Eureka. So if you reduce quadrant 1, quadrant 2, quadrant 3, quadrant 4, meaning that a 13 is actually a 4. So instead of a 35, this will be a 24 for the sum of this. And like 1 and 3, 1, like, if you start to reduce it, I believe you get these numbers. Now if you get those numbers, these two sum to 56, these two sum to 103, they come to 159 total. 48, 81 from here. The 129 plus the 159 is 288. 288 subtracted from 4251, which is the total of the white space, is 3963 before I start to mess with it. 3963 minus 3858 is 105, so it means I'm 105 off. Cool. What do I see in this, in the white space? Look, you have an O, an I, a V, and a C and a D, where I counted only for the Roman numerals of these, not the letters. Now an O is 15th letter. That's a 1 or an I. I is the 9th letter. The V is the 22nd letter. That's the 3rd letter. That's the 4th letter. Cool. So I'll look at, yeah, we need 105. If we look at the O, I, V, C, D, it's 15, 9, 22, 3, 4. It sums to 53. Take 53 off 105, you get 52. 52 is a little more like the alpha to omega. But let's say if we're playing with, like, you know, the Roman numerals here, we need the XLM. This is one of the two ways of looking at it. We need the XLM. But because you have a 24, 12, I wrote it wrong. That's a 12. I did the math right, but I just wrote it wrong. Alright. Alright. 4, 2, and 3 is 9, 10, 11, 12. Yeah, that's right. So 24 is the letter X, 12 is the letter L, 13 is the letter M. They sum to 49, but you have to group these, so you have to have the bubbles. You get 52. Or if you look at everything above, when I'm reducing these, okay, 1 and a 3 is a 4, great. But a 5 and a 5 is a 10. A 5 and a 5 is a 10. But I count this as a 2 because a 1 and a 0 is a 2. But I didn't count for the 10. Didn't count for the 10 here, didn't count for the 10 here, didn't count for the 10 here. And didn't count for 11 here, didn't count for 11 here. I need 52. 10, 10, 10, 11, and 11 is 52. The 9 and the 1 don't count as a 10 because the circle 9 is a 10. It's not... That's the thing. That's the only part I don't like about this proof. But if you look at it, and you need 52, you have a 10, 20, 30, 40, 50 with 2 because this is 11s, and you get your 52. So essentially, if you subtract everything from the white spaces, if you sum them, minus the cells, minus the numbers in the cells, minus the total of the sum reduced of the cells, and minus the letters in the Roman numerals in the cells, and minus the double digits in the cells, comes exactly to 3858, because you find the 52 and you get the 0. So basically it's 4,251 becomes 3858 when you actually count for everything. 3858, there's 1, 2, 3, 4 things. The swastika is the 5th thing. 3858 times 5 is 19,290, but I think there's a +1 needed because this swastika still isn't circled. So not only right now have I proven how the sum of the swastika is 5 times the number of cellular energy devices, but when you sum the white space and account for the number of cells, the number of numbers in the cells, what the numbers reduced to in single digits of the cells, and you account for the letters involved in the Roman numerals of the cells, and you account for the double digits that are not accounted for, and the only cells in these bubbles that make it past 10 are 55, 55, 55, 174, 174. 91 does it too, but 91's different. It's a circled 9. It's not like you're adding anything. It seems different. Or I'm 10 off. Right? So, I had a Wunderbar today. I had a Eureka. Okay? My 3rd attempt at this, which took me like minutes after work. But we are 3:27 in the morning. All is well. You know, sitting in the place having a swastika math happening and people are walking by. I don't know what the hell that means, but like, yeah, I'm onto something. Okay? 3,858 magnets are needed in that cellular energy device. I need to make 5 of them. I need to have them positioned in an array here, 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 and here, and here. Sorry, 1, 2, 3, 4, 5, and the 1 is an empty fishbowl of water with a bunch of stuff in the water, doped, with a big piece of copper with the magnet on the end. And that magnet on the end will bring it back to the beginning of the device where the input power comes in. And eventually, after time... Okay, I have a coaster that says pi. they probably don't do what I do, which makes them useless. You know? I don't appreciate useless people or things. But this is not useless. This... no. I don't appreciate unuseful people, perhaps I should say. But, you know, it is what it is, it isn't what it isn't. If you can prove this, you know, like, go for it. But you gotta reduce it. Remember that when you're adding this shit. 6, 7, 8, 9. 9 and 7, 16. 16 and 1 is 17. 17 and 2 is 19. So, like, literally these numbers here, quadrant 1, these numbers here are basically the reduced numbers. So that's what you got to work on. If that actually sums to 159, I know that there's 48 cells. I know that there's 81 numbers in the cell. So there's the 129 factor. I think there's a 159 factor. I think there's a 53 factor, and I think there's a 52 factor based on the 52U. I don't think this one counts. I think that one counts as a 10, that one counts as a 10, that one counts as a 10, that one counts as an 11, that one counts as 11. And that one, because it has a 1, is different. That's the only way I can put it together. But anyways, my argument from ignorance got interesting after 1 day and 3 iterations of my swastika math, because I watched Inglourious Bastards, and they like to carve swastikas into people's heads, because when they go home to that island, they're not gonna wear their uniform anymore. And no one told him he couldn't carve a swastika in that fucker's face. Wow. Anyways, this is more proof, I think, that you need 5 of these actually built in real life, not a model. But the math is on my board. To make life better for you and your family and every other human being in this place. In this place. But if this ever-changing world in which we live in makes you give in and cry, da-da-da, live and let die. Live or let die? Pfft. Not on this place. Because saying on this place would be retarded. As in incorrectly wrong.